In this video, we'll be going through lesson 4-7, where we're looking at exponents and multiplication. So we're going to be looking at what you do when things with the same base are being multiplied and how you can combine their exponents. So, multiplying powers with the same base. To multiply numbers or variables with the same base, you're going to add the exponents. So when they say same base, remember that the base is the large number and then the little number is the exponent. So for this first example, they have 2 to the third times 2 to the fourth. Since those have the same base, base of 2, you can add the exponents. So 2 to the third times 2 to the fourth is really the same as 2 to the 3 plus 4, because we took those two exponents, which is really the same as 2 to the 7th. Okay, let's pretend that I have a to the smiley face times a to the n, a to the star instead of m and n. We're going to do smiley face and stars. Okay, so they have the same base, so I just add the exponents, right? So it would still be a to the smiley face plus star. Okay, so no matter what the exponents are, if the two things that are being multiplied have the same base, you add the exponents together. Okay, the other half, this is going to be if you're finding a power of a power. Miss Keel likes to call these any outies. Okay, because they're going to have an exponent on the inside of the parentheses and an exponent on the outside of the parentheses. So when you're finding the power of a power, you're going to multiply the exponents. So for this first example, we have 2 to the third on the inside of the parentheses to the fourth on the outside. So see how it's any outie? Okay, so you're going to multiply the exponents. So really, that's the same as 2 to the 3 times 4, which is just 2 to the 12. Okay, we're going to use our smiley face and our star again. So if this is a smiley face and this is a star, I have a to the smiley face times star. Okay, so for any outies, you're going to multiply the exponents. For ones where they just have the same base and they're being multiplied, you're going to add the exponents. So let's look at this first one. It says simplify each expression. 5 to the 2 times 5 to the 3. Okay, so since those have the same base of 5, you're going to add the exponents. So you end up with 5 to the 2 plus 3, which is really 5 to the 5. And since we have a number base and a number exponent, we can actually figure out what that is. So remember, 5 to the 5 is going to be 5 times 5 times 5 times 5 times 5. Okay, 5 times 5 times 5 times 5. We get 5 times. Okay, so when you do that math, what do you get? Okay, you should get 3,125. Okay, for this next one, we have x to the 5 times x to the 7 times y to the 2 times y. So we have x's that are the same base, and then we have y's that are the same base. So we're going to have a set where we do the x's and we combine their exponents, and then the y where we combine their exponents. So since it's x to the 5 times x to the 7, we have x to the 5 plus 7. Okay, because we're adding those exponents. And then since we have y to the 2 and just a y, remember that when it's just a y, really it has an exponent of 1, telling you that there's only one y happening. So this is going to be 2 plus 1. Then we combine those. So x to the 5 plus 7 is really x to the 12. And y to the 2 plus 1 is really y to the 3. Okay, so you write your final answer like that. Remember, in your final answer, when it has variables and such, you don't need to have a dot between them. X to the 12, y to the third. So you can just write it like this, making sure that your exponents are smaller and up into the right-hand corner of your number or variable, depending on what the problem is. All right. So I'm going to do A with you to show us how we want to show our work. So we have 2 to the 2 times 2 to the 3. So all I did was rewrite the problem there. Then I'm going to have 2, and I'm going to add those exponents, right, because they have the same base. So I'm going to say to the 2 plus 3, and then I'm going to say 2 to the 5. And then since I have a number with an exponent, I'm going to actually do the math. 2 to the 5 equals 32. If I do 2 times 2 times 2 times 2 times 2, I'm going to get 32 as my final answer. If it's something with like a variable and then an exponent, you would stop here and you wouldn't get to like a final number answer. All right, so you're going to pause the video and do B and C, and then we'll go over them together. All right, so what we should have done for B, we had m to the 5 times m to the 7, which means we rewrite that as m to the 5 plus 7, and then m to the 12. Since it's a variable with an exponent, that is our final answer. Very similarly over here, we have x to the 2 times x to the 3 times y to the 4th. So we're going to have x to the 2 plus 3 times y to the 1 plus 4. And then we're going to combine those to our final answer. So it's going to be x to the 5, y to the 5. And that is our final answer. Again, noting that in the final answer, we do not have a dot between those variables. All right, when you're ready, go ahead and flip over your paper, and we'll start on the second page. So sometimes you're going to have numbers attached to variables. So like this example, it says 3a to the 3rd times negative 5a to the 4th. You're going to have to separate things out so that you can use the commutative property where we put the like things together. So in order to do that, if you look at 3a to the 3rd, that's really, you can chop it in half, right? That's really 3 times a to the 3rd. And then the other one, negative 5a to the 4th, you can chop that apart. And that's really negative 5 times a to the 4th. So instead of having these two bigger pieces, you can break it apart into 4 pieces, because each one of those, 3a to the 3rd, negative 5a to the 4, all of those are being multiplied. Okay, so I'm going to explain that one more time. So the 3a to the 3rd you can separate, because 3a to the 3rd, when they're written like that, means they're being multiplied. So you can write that as 3 times a to the 3rd. This next one, negative 5a to the 4th, again, they're being multiplied. That's implied, right, when it's a number next to a variable. So we have negative 5 times a to the 4th. For this next step, all they did was put them in commutative like things together order. So 3 times negative 5 times a to the 3rd times a to the 4th. So all they did was take those pieces and kind of sort them out. So you had the two numbers and then the two a's, because now you have same bases and you're going to be able to do the exponent trick on those. Negative 5 and 3, when we combine those multiplying, we're going to get negative 15, right? And then we have a to the 3 plus 4 because we add those exponents, just like we did on the other page. So the answer for this is just going to be negative 15a to the 7th. Excuse me. All right, now we have some any-outy examples. Any-outy. So when we have any-outy ones, what do? We multiply the exponents. Okay, so 2 to the 3rd, all of that to the 3rd power is going to be 2 to the 3 times 3, which is 2 to the 9th. And when you do that, 2 times 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 2, you should end up with 512. Okay, same thing here. We have g to the 5, all of that to the 4. So we're going to multiply exponents. So we have g to the 5 times 4, which is just g to the 20. And that's where we stop because that's a variable and we can't keep going. Okay, so let's do some quick checks. So the first ones are going to be like that top example where we have to break things apart. So I'll do A with us. So when we're looking at this, we've got 6, and then we've got a to the third, and then we've got 3, and then we've got a, right? So those are 4 pieces because I can break these apart. So when I rewrite that, I can rewrite it as 6 times a to the third times 3 times a. Notice that I didn't sort the first time. All I did was separate out because I don't want to get confused. So I took each piece and I made it its own part, but I didn't sort them out yet. So that's going to be step 1. Step 2 is where you're going to sort them. So you're going to move the numbers to the front. So you're going to have 6 times 3, okay, because those are your 2 numbers, times a to the third times a. Okay, so now you have like things together, but they all came from above. We just reordered them. 6 times 3 is going to be 18. And then we have a to the third and an a, so we end up with a to the 3 plus 1, because we have to show that step where we're combining the exponents. And then we end up with 18 a to the 4 as our final answer. So that first step, we just broke them apart. Here, we'll write this. Break apart. The second step, reorder, multiply, and show exponent work. And then that last step is the answer. Okay, so break them apart, reorder them, do that multiplication for the numbers, and then show your work for the exponents. And you end up with 18a to the 4. Worth noting on the next problem, because you're going to try it by yourself, keep in mind that this is a -5 when you break it apart, and this is a -3 when you break it apart. So keep that negative with the number for each of those. Okay, so we're going to go ahead and pause the video, and you're going to work on B and C. And then when we come back, we'll go over those. All right, so let's do B first. So we end up with, when we break those apart, -5 times c to the 2 times -3 times c to the 7. Because that first step, all I did was break them apart, but I left them in the same order they were in. Then I'm going to reorder them, and I have -5 times -3 times c to the 2 times c to the 7. Okay. And then my next step, I'm going to multiply and show my exponent work. So I end up with -5 times -3 is a +15, because we had a negative times a negative, times c to the 2 plus 7, okay, because I show my work for the exponents. Then I'm going to combine all that, right? I'm just going to have 15c to the 9 as my final answer. Again, noting that in the final answer, there is not a dot between those, because when you have a number next to a variable, the multiplication is implied. All right, for C, I'm gonna have breaking apart 4 times x to the 2 times 3 times x to the 4. Okay, all I did was break them apart. Then I'm going to reorder them. 4 times 3 times x to the 2 times x to the 4. So that's how I can put them in new order. So the numbers were next to each other and the variables were next to each other. 4 times 3 is 12 times x. And we're going to show our work for those exponents. 2 plus 4. So then my final answer is 12x to the 6th. All right, let's look at some innie outies. So I'll do A with us. So we have 2 to the 4, all to the 2. 2 to the 4, all to the 2. Remembering that we multiply them, so this can get written as 2 to the 4 times 2. When we do that math, it's just 2 to the 8. Then you need to actually multiply this out. 2 times 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 2. Okay, and you should end up with 256 is your final answer. Again, when you have like a number with an exponent and it tells you to simplify the expression, you're going to want to do all the math. When you have variables, you're going to stop at this step that has the exponent. So go ahead and pause the video and do B and C on your own, and then we'll come back together and go over them. All right, so for B, what you should have done is C to the 5 to the 4. Then we're going to say C to the 5 times 4. And C to the 20 is our final answer. Any outies are pretty straightforward. M to the 3rd, all of that to the 2 is really M to the 3 times 2, which is just M to the 6 as our final answer. All right, that's going to wrap up lesson 4-7, where we're looking at exponents and multiplication.